On July 1st, 2025, a small object was picked up by the Atlas Survey Telescope atop Mauna Loa, Hawaii. At first, the discovery log was routine. A faint moving point, magnitude 19, drifting slowly across the background stars. Yet within hours, automated orbital calculations began spitting out impossible numbers. The object, provisionally named C2025A3 Atlas and later designated 3I Atlas, wasn't just another comet. Its path didn't close around the Sun, it escaped it. In other words, this was an interstellar visitor, the third ever detected after 1I Oumuamua in 2017 and 2I Borisov in 2019. But almost immediately, astronomers realized it was unlike either of its predecessors. At first, scientists expected a frozen chunk of dirty ice, maybe a few hundred meters across, to drift lazily through our solar system and disintegrate near the Sun. But 3I Atlas wasn't lazy. As it drew closer, it accelerated, faster than solar gravity alone could explain. And its albedo, or reflectivity, didn't behave like that of a dusty comet. Instead, its spectrum showed metallic hints, even traces of nickel-iron ratios known only from refined alloys. By August, observatories from Chile to Japan had joined in the campaign. NASA's NEOWISE satellite tagged it as unusually bright for its size, suggesting something massive or highly reflective on its surface. The James Webb Space Telescope, JWST, detected extreme polarization, a negative scattering effect never seen before on a cometary body. The anomaly sparked headlines. NASA confirms. Third interstellar object defies known physics. Still, the general public wasn't paying much attention. The world was busy with political tensions, economic slowdowns, and another heatwave summer. Only a handful of astronomers lurking on internal forums and encrypted Slack channels realized that something truly new had entered the solar system. By late September, 3I Atlas was inbound toward its perihelion, the point of closest approach to the Sun, calculated for October 29, 2025. Every predictive model said the same thing. The object should either break apart under solar radiation or release an enormous gas cloud that would make it easy to observe. Instead, as perihelion approached, 3I Atlas tightened its glow. Its coma shrank. Spectrographs detected less water vapor than in a desert rock. And yet, paradoxically, its luminosity quintupled in under 3 hours. Something, or someone, was pushing back against physics itself. On October 29th, at 1642 UTC, 3I Atlas reached its perihelion. It should have been a predictable moment. Solar radiation hits the surface, volatile compounds explode into space, and the comet brightens due to its expanding coma. Instead, it performed a maneuver so bizarre that even veteran astrophysicists fell silent on live telemetry calls. At the exact moment it passed closest to the Sun, its acceleration vector reversed. For about 7 minutes, the comet slowed, relative to its predicted trajectory, as if applying cosmic brakes. NASA's Solar and Heliospheric Observatory, SOHO, cameras caught a sharp, angular shadow in its wake. The Jet Propulsion Laboratory's tracking data flagged a non-gravitational acceleration signature equivalent to 135 km/date, several orders of magnitude above normal comet outgassing. The European Space Agency confirmed the acceleration had both radial, outward from the Sun, and transverse, sideways, components, meaning something inside the object was actively altering its motion. But 3I Atlas didn't disintegrate. It survived the scorching proximity intact and even grew brighter. Within hours, it was 5 times more luminous than the models predicted. Then came the color shift. Instead of the warm, golden red typical of comets, it turned an electric blue, bluer than the Sun itself. The event was recorded by multiple instruments, including the Very Large Telescope in Chile and the Subaru Observatory in Hawaii. One researcher described the spectrum as unnaturally clean, as if we were looking at reflected light rather than emission. Within 24 hours, the data vanished from NASA's public portal. The reason? The ongoing federal shutdown that had begun on October 1st had forced many non-essential data channels offline. But internal chatter within the planetary science community suggested something stranger. That the data wasn't merely delayed but classified. On October 31st, Congresswoman Anna Paulina Luna publicly demanded the release of all 3I Atlas observational records. The Pentagon's All-Domain Anomaly Resolution Office, AARO, replied tersely, "Outside our jurisdiction." Meanwhile, amateur astronomers noticed that live comet tracking feeds were quietly being scrubbed from public archives. The mystery deepened. Was this a simple coincidence of timing, or the quiet beginning of a cover-up? By early November, observatories expected to detect a massive dust and gas cloud expelled from 3I Atlas during its perihelion passage. According to established physics, around 13% of its mass should have vaporized, creating a glowing plume visible across millions of miles. But there was nothing. No dust trail, no debris, no sublimation signature. The cloud was missing. Instead, radar imaging from ESA's solar orbiter revealed something unexplainable. A fine, symmetrical field of ionized particles surrounding the comet, rotating opposite to its spin. "It's like it's charging itself," said one anonymous European astrophysicist quoted in Nature. "We've never seen anything like it, a self-contained electromagnetic shell." Speculation exploded online. Some claimed it was hollow, a derelict probe, perhaps an alien solar sail that had entered our system long ago. Others argued it was an exotic mineral fragment from a supernova remnant. Its metallic crust re-radiating sunlight in ways we didn't understand. Harvard astrophysicist Avi Loeb, already known for controversial theories about one-eye Oumuamua, wrote a new preprint paper suggesting that artificial origin cannot be excluded without direct spectroscopic sampling. NASA, however, officially dismissed the idea, calling the data inconclusive but fascinating. Still, something had changed in the tone of official communications. By mid-November, all major space agencies, NASA, ESA, JAXA, and even China's CNSA, coordinated a joint observation embargo citing data harmonization. In plain English, they were watching but not telling. Meanwhile, amateur astronomers continued to observe. On November 12th, a group of Chilean enthusiasts using the Atacama remote array captured time-lapse imagery that stunned experts. For a brief 0.7 seconds, 3I Atlas emitted a pulse of blue-white light, not a flare or reflection, but a concentrated beam aimed outward into deep space. Then it was gone. Within days, that video disappeared from YouTube and other platforms. Copies circulated briefly on encrypted forums before being removed under national security notices. For the first time since its discovery, people began to wonder aloud whether 3I Atlas was truly natural, or whether humanity was witnessing the first interstellar technology pass through our star's gravity well. Faded, its rotation slowed, and its radio silence deepened. Every major observatory continued to collect faint data, though none publicly discussed their findings. What remained were questions. Big ones. Why had the object survived its perihelion intact? Why had its acceleration reversed against solar radiation? Where did the missing dust cloud go? And what exactly was that pulse of light? In January 2026, declassified European data quietly confirmed one last anomaly. A brief, wideband electromagnetic burst synchronized with the comet's closest solar pass. It wasn't random noise. It carried structured periodicity, the mathematical equivalent of a signal. The frequency pattern mirrored a hydrogen spectral baseline, universal in astrophysics as a cosmic constant. In other words, it looked intentional. But to this day, no agency admits to detecting it. NASA has maintained radio silence on 3I Atlas since late October. The official line, further analysis ongoing. The public version of the Minor Planet database now lists 3I Atlas as inactive, outbound interstellar object. Nothing more. Yet private observatories report that even as the comet dims, it remains oddly reflective. Its albedo hasn't decreased in proportion to distance. Some astronomers theorize that a reflective shell or composite surface still glints under sunlight, maintaining visibility far beyond expected limits. Others whisper that it may still be maneuvering, adjusting course ever so slightly, out toward the dark between the stars. The human fascination with such a mystery is inevitable. We name comets after discovery programs. We catalog their orbits. We fit them neatly into equations. But sometimes the universe sends something that doesn't fit the equations, something that acts instead of merely reacting. Whether 3I Atlas was a natural cosmic wanderer, a relic of an ancient civilization, or just an anomaly of physics we don't yet grasp, one fact remains. Every telescope on Earth turned to see it. And for one moment, humanity looked up, united not by fear or faith, but by pure electric wonder at what might be watching us back.